Welcome to a new problem solving session. You can see this is the first problem of a new playlist, and the problem is related to the thermal equilibrium. So let's read the statement of the problem first. And we have got three bodies with same mass and same specific heat capacities. That is important. Their masses are same. So is their specific heat capacities, and they are heated to different temperatures. Initially their temperatures were different. If the first body is brought into thermal contact with the second body, then the temperature T1 is established. This is the equilibrium temperature when first and second body are brought into contact with each other. The temperature is finally set to T1. If the first body is brought into contact not with the second body, but with the third body, first and third, then the temperature T2 is established. This is again the equilibrium temperature. If the second and third bodies are brought into contact with their initial temperatures, then the temperature T3 is established. Fine. What will be the established temperature if all three bodies are brought into thermal contact with their initial temperatures? So this is we all know how the bodies interact with each other. They lose, one of them loses some temperature, and the other one gets it, and we write this in terms of energy, that somebody is losing energy, that is mc delta theta or mc delta t, and serum m and c are same, so there is no problem. And c is the specific heat capacity I'm talking about. So let us denote first that the initial temperatures of the first, second and third bodies are simply T1, T2 and T3. These are the initial temperatures of all three bodies, T1, T2 and T3. They are all different. And the desired steady state temperature when all three bodies are brought into thermal contact with each other is say theta. This is the final required temperature, south temperature in this case, when all three bodies come into equilibrium, thermal equilibrium simultaneously, thermal equilibrium. So the heat balance equation for the cases when all three bodies are brought into contact has the form something like m. I would like to, m is not because okay, I can write it, mc T1 minus theta for the first body plus mc T2 minus theta for the second body, and mc T3 minus theta for the third body, and this all will be equal to 0. This is the heat balance equation. That is how I learned to write the heat balance equation. And here you can simply write that or simply get that theta, the value of theta becomes T1 plus T2 plus T3, T1 plus T2 plus T3 by 3. This is our equation 1. And now we move to write down the heat balance equations for the pairwise thermal contacts of bodies. T1 comes into contact with the first body comes into contact with the second body, first body with the third body, and second and third body. So if you can write something like that, you can write for the first pair simply as C T1 minus T1, and first and second body C T2 minus T1. I'm not writing the value of m, because after all I'm going to equate them to 0, so m will get cancelled out. But if you want, I can avoid writing c also. But one thing I'm writing and another thing I'm omitting. Let it happen. And then first body and third body, and the established temperature was T2. So one of them must have lost something. I'm writing in this manner: C T1 minus T2, the final temperature established, plus C T3 minus T2. First and second pair was brought into contact with each other, and finally the second and third was brought into contact. So for them I can write the equation C T2 minus T3, gain on loss, plus C3 T3 minus T2 minus T3 capital T3 minus T3. Kindly take care of this small t and capital T, and that will be equal to 0. And if you solve them, you will simply going to get some what 2T1 plus 2T2 plus 2T3 equals 2T1 plus 2T2 plus 2T3. Oh, it is simply T1 plus T2 plus T3 equal to T1 plus T2 plus T3. Okay, fine. So we got the result. We wanted the value of, this is our second equation, and we wanted to get the value of theta, and T1, T2, T3 were unknowns, and but this capital T1, T2, T3 were knowns. So the final temperature, when the established temperature, if all three bodies are brought into thermal contact with each other, will simply becomes theta equals T1 plus T2 plus T3 by 3. And that's all. Thank you for watching.